Something remarkable has happened to A23a, the world's biggest iceberg. For months now it has been spinning on the spot just north of Antarctica, when really it should be racing along with Earth's most powerful ocean current. Scientists say the frozen block, which is more than twice the size of Greater London, has been captured on top of a huge rotating cylinder of water. It's a phenomenon oceanographers call a Taylor column, and it's possible A23a might not escape its jailer for years. Usually you think of icebergs as being transient things, they fragment and melt away. But not this one, observed polar expert Professor Mark Brandon. A23a is the iceberg that just refuses to die, the Open University researcher told BBC News. The berg's longevity is well documented. It broke free from the Antarctic coastline way back in 1986, but then almost immediately got stuck in the bottom muds of the Weddell Sea. For 3 decades it was a static ice island. It didn't budge. It wasn't until 2020 that it refloated and started to drift again, slowly at first, before then charging north towards warmer air and waters. In early April this year, A23a stepped into the Antarctic Circumpolar Current ACC, a juggernaut that moves 100 times as much water around the globe as all Earth's rivers combined. This was meant to put boosters on the near-trillion-ton berg, rifling it up into the South Atlantic and certain oblivion. Instead, A23a went precisely nowhere. It remains in place just north of South Orkney Islands, turning in an anti-clockwise direction by about 15 degrees a day. And as long as it does this, its decay and eventual demise will be delayed. A23a has not grounded again. There is at least 1,000 meters of water between its underside and the seafloor. It's been stopped in its tracks by a type of vortex first described in the 1920s by a brilliant physicist, Sir Geoffrey Ingram Taylor. The Cambridge academic was a pioneer in the field of fluid dynamics, and was even brought into the Manhattan Project to model the likely stability of the world's first atomic bomb test. Professor Taylor showed how a current that meets an obstruction on the seafloor can, under the right circumstances, separate into 2 distinct flows, generating a full-depth mass of rotating water between them. In this instance, the obstruction is a 100 km wide bump on the ocean bottom known as Peary Bank. The vortex sits on top of the bank, and for now A23a is its prisoner. The ocean is full of surprises, and this dynamical feature is one of the cutest you'll ever see, said Professor Mike Meredith from the British Antarctic Survey. Taylor columns can also form in the air. You see them in the movement of clouds above mountains. They can be just a few centimeters across in an experimental laboratory tank or absolutely enormous as in this case, where the column has a giant iceberg slap-bang in the middle of it. How long might A23a continue to perform its spinning top routine? Who knows, but when Professor Meredith placed a scientific buoy in a Taylor column above another bump to the east of Peary Bank, the floating instrument was still rotating in place 4 years later. A23a is a perfect illustration once again of the importance of understanding the shape of the seafloor. Submarine mountains, canyons and slopes have a profound influence on the direction and mixing of waters, and on the distribution of the nutrients that drive biological activity in the ocean. And this influence extends also to the climate system. It's the mass movement of water that helps disperse heat energy around the globe. A23a's behavior can be explained because the ocean bottom just north of South Orkney is reasonably well surveyed. That's not the case for much of the rest of the world. Currently, only a quarter of Earth's seafloor has been mapped to the best modern standard. For months, a gargantuan iceberg has been slowly spinning in one spot in the Southern Ocean, and it could continue to stay trapped in this vortex for quite some time, experts say. As the world's largest iceberg, the Colossus A23a is of great interest to scientists, who have closely monitored the frozen block since it calved from Antarctica's Filchneron ice shelf in 1986. Now, the iceberg's fate is unclear as it remains stuck as a result of a rare set of circumstances that scientists say is unprecedented. This has never happened before as far as we all know, said Dr. Les Watling, a professor emeritus of life sciences with the University of Hawaii at Manoa, in an email. The roughly 3,672 square kilometer 1,418 square mile chunk of ice, slightly bigger than Rhode Island and more than twice the size of the City of London, drifted over a seamount and got stuck in a phenomenon known as a Taylor column, a spinning vortex of water caused by ocean currents hitting the underwater mountain. The currents create a cylindrical motion of the water above the seamount, where the iceberg now floats.
A mass of solid ice, 3 times as big as New York City, and it's on the move for the first time in decades. This team of scientists saw it up close this month.
Sailing straight through this mist, knowing that there's an iceberg only a mile away, but not quite seeing it yet, and then suddenly just seeing this expansive white wall on the horizon.
Laura Taylor took water samples near the iceberg to better understand how they affect ocean life.
We saw orcas and birds and things like that, which wouldn't normally be that populous in that area of the water, and yet they were all kind of gathered around the iceberg, which also made it really interesting.
Known as A23a, it broke away from the Antarctic coastline in 1986, but quickly became stuck on the ocean floor. Now it's moving again, north, possibly posing a problem for South Georgia Island, east of South America.
It could potentially block penguin colonies if it comes near shore and disrupts wildlife in that regard.
While A23a broke off as a result of its natural life cycle, similar events are expected to become more common as the world warms.
We're going to be seeing more and more of these ice shelves breaking away and causing icebergs the size of this one and many smaller ones as well.
Scientists are studying ice shelves closely because they play a crucial role.
They keep the glaciers from flowing out onto the ice, out from the land and onto the ocean. And so that uncorking of the bottle will allow ice to move from the land and into the water, and that will create a sea level rise.
Researchers are trying to better understand the physics of how all this happens and what it means for the future as the climate changes. Ben Shingler, CBC News, Montreal.